Good evening, everyone. Thank you for coming to this tutorial session on discrete mathematics. We'll be discussing week 5 assignments from previous iterations of this course, and the questions would mostly be related to functions. I'll get started. So I'll share my screen. Okay. So these are the week 5 questions. Let's get started. So coming to the first question, which of the following mapping does not represent a function? So you have four options. So I hope you can see the four options in the screen itself. So the first one, you have 1, 2, 3, 4 on the domain, and you have 2, 4, 6, 8 in the range. And one is mapped to 2, 2 to 4, 3 to 6, 4 to 8. And similarly, there are other three types of mappings. Now, which of this is not a function? Can anyone take a guess on what should be the right answer for this question? Okay, option C. So yeah, you're right. Option C is the right answer for this question. I'll explain why this is option C is not a function is because you see -1 and 1 have a common pre-image 4. So there cannot, so for every element in range, there should be a unique mapping in the domain. So it could be that -1 is can be mapped from 6 and 2. So things like this can exist. So 2 to 6 and 2 to -1 could have existed, but the same num the same element in the domain cannot have multiple images in the range. So that is why it is not a function. Uh, Elements in the domain cannot have multiple images. So for every element in the domain, there should be a unique image in the range, and that image could have another pre-image in the domain. That is all right, but every element in the domain must have a unique image. So basically what this means is things like, if you remember, in terms of x and y, so you have x, and let's say you have f of x like this, and let's say you have a mapping like this. So suppose like this. So what it means is that at a particular x value, let's say x star, you have two values of fx. So fx is your range and x is your domain. So such a curve is not a function. Uh, all right. So we'll move on to the next question. I hope this is clear to everyone. All right. Okay. So coming to question number 2, a function f is dash if and only if each element in the codomain or range, this is sometimes known as codomain or range of f, have has at least one corresponding pre-image in the domain. So what this figure looks like is that you have a domain and you have a codomain. Okay, so it says that uh, each element in the codomain, if we take any element in the codomain, has at least one corresponding preimage in the domain. So they have come from somewhere in the code. They can have multiple pre-images, at least one. So at least one. It could be like so. Every element in the codomain has a pre-image in the domain set. So what kind of a function do you think this satisfies this property among both one one? Is it one one onto both or none? Which do you think? Okay, someone is saying onto. Yeah, onto is the right answer for this question. So such functions where every element in the codomain has at least one corresponding pre-image in the domain is known as a onto function. Since we have been given only this much detail, we can't say whether it is a one as well, but it is definitely an onto function. Therefore, option D is the right answer for this question. So we cannot tell it is 1 because it might be that there is some element in the domain which has no mapping, like it has no mapping in the codomain. So in such a case, it cannot be a 1 function. But it is still an onto function. So option D is the right answer for this question. Let us move on to question number 3. So we have been given a function f where 0, 1, 2 and 0 to 4 is given by fx equal to 2x. So what function is this? So I'll again draw this function. So you have 0, 1, 2 and you have 0, 2, 4. Okay. So now they are saying that you have a mapping given by this fx equal to 2x. So it is 0 into 0 is 0, 0 into 2 is 0, 1 into 2 is 2 and 2 into 2 is 4. So this is the kind of mapping. What function do you think this is? So your options are 1 onto both or none. What do you think this both 1 and onto, right? So it is 1 because uh, every element in domain has a unique image. It is onto because every element in codomain has at least one preimage. So therefore, the right answer is both. It is 1 and onto. So I hope this is clear. Let us move on to the next question. So we have question 4. So what is the domain of the function f of x is uh, fourth root of x? So when we mention this function, we'll have to, it is not mentioned, but it is real valued functions. So such that fx takes only real values. It means fx takes only real values. So uh, now you have this function root of x4. Now can you tell me for which values of x it is real? Option B, right. So from 0 to infinity, which basically means the entire non-negative axis. So what happens is that if you have a negative number, let's say x equal to -1, then f of x fourth root of -1, this is complex. This is not a real number. Therefore, x cannot be from the negative. So x less than 0 will not give you not give real values. Therefore the domain of the function is 0 to infinity, right? S- so why not natural numbers? Natural n is a subset of the domain, it is not the exact domain. So if we call this domain D, so this n is will lie in the subset of D. So D is your entire non-negative axis, and so N is a subset but not the entire domain, and Z means integer, and if you remove 0 from the integer, it is saying that it also includes negative numbers, which is not possible. So A and D are not at all, means they are incorrect because they contain the negative sides. C is a smaller set of the actual domain. Therefore, the best answer is option B, 0 to infinity. Okay, I hope that was clear to everyone. Now let us move on to the next question. So you have this function fx equal to x square minus 1. So what is the range of fx? So range of fx means what values f of x can take. So what do you think, what values f of x can take? Right, you're right. So option D, f of x can take from -1 to infinity. Why? Because this function x square will always be greater than equal to 0. So if x belongs to real numbers, x square will always be 0. Greater than 0, x square minus 1 will be greater than -1. So this function f of x equal to x square will contain any number that is greater than -1, and therefore option D is the correct answer. Again, it will option A cannot be right because it contains numbers lower than -1 as well. Option B is again a subset of the range. So if we call this R, note that this R is different. Okay, I'll use a, let me call it Q. So for now, Q represents a range of fx and x, and this R with a dash represents real number. So 0 to infinity is a subset, proper subset, actually proper subset of Q. So it does not capture the entire range properly. So there can be numbers from -1 to 0 as well. Therefore, uh, option B is only partially correct. Option D is the right answer, and C and A cannot be correct because they contains numbers which are less than -1 as well. I hope that is clear. Uh, Let us move on to the next question. Okay. So you have, if if you have a function defined from A to B is a bijection. Which of the following best defines the relationship between the cardinalities? Okay, so okay, before solving this question, we'll break it down. So, what do you think is a bijection? What is a bijection? Can anyone say what is a bijection? It's 1 1 and onto, right? So, it is 1 1 and onto both. So, it is a bijection. Now, if it is 1 1, if it is 1 1, what does, so you have this set A, you have this set B. So let's say A and B. What does 1 1 mean? That every element in A must have a image in B. So there could a unique image, one image only. So there could be multiple elements in A that can be mapped to the same image, but every element must have at least at least not only one image in B. So what do you think the size of B will be? What do you think about the cardinalities of A and cardinality of B? Is it cardinality of A is more than B, or cardinality of B is more than A, or are they equal? Cardinality of A is less than B. Yeah, you are right. So it would be cardinality of A is less than B because all the elements in A will be covered. So they every element will have an image, but every element in B may or may not have a pre-image because it is just 1 1. It is not, we don't know whether it's 1 1 and onto. If we just consider it as 1 1, there could be some elements in B that may not have a pre-image in A. Now come to the second one, onto. So you have again a set A and set B. What does onto mean? It means that every element in B has a pre-image in A. So again, they can have at least one. So they can have multiple pre-images also, but every element in set B has a at least one preimage. Means all elements in B have been covered, so they can be reached from some elements in A. So you have, so what do you think about the cardinality of A and B if it is an onto function? Cardinality of A is greater than B, and same thing is it's less than A. So right, so A is greater than B. So now if we combine these two both, it leaves us with these two inequalities can only be possible if the cardinalities are the same. So in a case of a bijection, the cardinalities of the set has to be the same. So option A is the right answer for this question. Let us move on to the next question. Again, you have a function uh, f defined from A to B is a function where the set A has 6 elements and set B has 2 elements. What is the number of all possible functions from A to B? So you have, let me draw it here. You have set A and you have set B. So uh, you have 6 elements, 1, 2, 3, 4, 5, 6. and you have two elements in B, 1 and 2. So this is set A and this is set B. So what do you think? Okay, so how will we go ahead with this? So it is a function defined. So we are assuming that it is a like we assume every element of A is covered, means every element of A has a has an unique image in B. So first element, let's say this one, can be mapped to, let's say, the first one, or it can be mapped to the second one as well. So it could be either of this. So in one type of function it is mapped to the first one, in second type it can be mapped to second one. So there can, for every element in A, so let me write it like this: for every element in A, how many choices, how many mm, mapping choices are there? So what do you think? What is the answer to this question? How many mapping choice does every element in A have? Right, two. So the right answer is two, because there are two elements in B. Now, uh, therefore, total number of mappings possible. What do you think is the answer? What is the total number of mappings possible? 2 to the power 6, right? Is 2 to the power 6. Why it is 2 to the power 6 is like this. So it's basically, this is from your first lecture. You have six elements: 1, 2, 3, 4, 5, 6. And each of these six elements can be mapped to two elements from B. So every element has two choices to be mapped to either B or either elements in B. So one mapping could be that the first one, this is the first element, is mapped to, let's say, the first element in B. The second element in A is mapped to, let's say, first element in B. And let's say the mapping looks like this. It could be like this, right? So what, uh, so let me try to fit it here. Yeah, so what this mapping would look like is that, so you have a mapping from first to first, then from second to first, then third to second, for fourth to first, fifth to second, and sixth to second. So this is the kind of mapping you get. So this is how you, so since there are six elements and they have two choices, so you get 2 to the power 6 total possible mappings. So why did we do it from the domain side, and why didn't we do it from the uh, i- codomain or the range side? So it would have appeared like this, that every element in the range set or the codomain set has six choices. So it could be like this. So you have six choices. So why is it not 6 to the power 2? So there are why not, why is it 2 to the power 6? Can anyone think about it and tell me why is it 2 to the power 6 and not 6 to the power 2?
Sir, I think only two of the elements from set A will be mapped, remaining will be not mapped at all.
Right. You are right. So while for a function, the pre-image, there can be multiple pre-image. There should be at least one pre-image. So it, like if you see the previous diagram where we have two choices for every green element, so it means we can take only one of the two choices. But for a function, it might be that it can take multiple choices out of the six choices in one column and multiple from the second column as well. So it is not that's so it won't come out to be 6 to the power 2. In the first case, it comes out to be 2 to the power 6 because we are choosing only one among the two red elements in each column, and therefore we have 2 to the power 6, which is not the same in the second case. So therefore 6 to 6 square is not the right answer for this question. So while finding out all possible mappings, you should always look from the domain set, because for a function, every element in the domain must have a unique image in the codomain. So it cannot have more than one image in the codomain. Then it won't be a function. So that makes our counting easy. So therefore we start from, so it is the, if it has m elements and n elements in B, so the total mapping would be m to the power n. I hope this is clear to everyone. Okay, so let us move on to the eighth question. So you have a function f and g, which are mapped from real number to real number, means fx is given as 2x plus 1 and gx as given as minus 3x. So x can take any real number in both f and g, and the output will also be a real number. That is obvious. So they are asking us to find what is g of f of 2. So it's a straightforward question. So first we'll find out what is g of f of x. So it is basically minus 3 of f of x, which is minus 3 into 2x plus 1, which is minus 6x mm, minus 3. So we just plug in 2. So g of 2 is minus 6 into 2 minus 3. That gives us minus 15. So option C, minus 15, is the right answer. So it is a pretty straightforward question. Uh, I hope you don't have any doubt in this question. We can move on to the next question. So again, you have a function that maps from the real number to real number and given by f of x. Uh, equal to 3x minus 5. So what is f inverse of minus 2? So what this means is that basically for what value of uh, x is f of x equal to minus 2. So basically here, what is the pre-image of minus 2? So this is what f inverse means. So how to find it? So it's again pretty straightforward. You have f of x as 3x minus 5. So if we arrange this, so we have 3x as f of x plus 5, or x as uh, f of x plus 5 by 3. So this is the x and this is your f of x. So if we plug in f of x on the right hand side, we get back x. So basically we can rewrite this statement like this: f inverse of x is basically x plus 5 over 3. So now uh, so or f inverse of 2, sorry, minus 2 is basically minus 2 plus 5 by 3, which is 1. So the right answer is option D, 1. Is that clear to everyone? Yes. Okay. I think it is clear to everyone. So feel someone is typing. Uh, Okay, so someone is asking to repeat it again. So we have this function 3x minus 5. So what is f inverse of minus 2? So what do we mean by f inverse of minus 2 is basically for what value of f of x is fx equal to minus 2. So we are given fx equal to minus 2. We are asked to find what value of x helps in achieving fx equal to minus 2. So basically it is what is the pre-image of minus 2. So how to find it is we write it down as fx equal to 3x plus 5, and we write it such that on the left hand side we have x and on the right hand side we have f of x. So if we plug in the value of f of x on the right hand side, we get back x, which is that x that helped in giving fx equal to minus 2. So now we know fx is equal to minus 2. So on the right hand side we plug in place of f of x we plug minus 2. So minus 2 plus 5 over 3 gives us 1. So that is how we get f inverse of minus 2 as 1. Okay, thank you. We'll take the final question of the session. So we have a function from natural number to natural number. So till now we are dealing with real number to real number. Now we have a function from natural number to natural number such that f of n is equal to n plus 7. So we have something like this. So you have 1, 2, 3, 4, let's say, and so on. These are your natural numbers and your f of n. So let me write it: n and f of n. So f of n would be 8, 9, um, 10, 11, and so on. Now they are asking what is this kind of function? So is it bijective 1 1 or onto? So bijective, like you mentioned, is a combination of both 1 1 and onto. So or is it not a function as well? So what do you think is the right answer? Can anyone take a guess? Okay, well, some Akanksha is saying it's 1-1, and Divya is saying it is a bijection. Bijection means it is both 1-1 and onto. So let us see what it is. So first let us see whether it is 1-1 or not. 1-1 means, again let us recall, 1-1 means every element in domain has an unique image. So your domain is your natural number set. So do you think that every element in the domain has a image? Yeah, it is obvious. So you take any number in the domain, any natural number, let's say 3, and you add 7 to it, you get an image that is 10. So like this, 3 to 10. Any number you say, you take 14, you get 21. You get 30, you take 38, you get 45, and so on. So it is definitely 1-1. So it is definitely 1-1. Now let us explore it, whether it is onto or not. So what does onto mean? Again, that uh, every element in range has at least one pre-image. So it can have one or more pre-image. Now tell me whether this is true or not. Can you give me an example where this is not true? Can you give me an exception where this statement does not hold? So your range is again your natural number. So give me one natural number which does not have a pre-image in uh, the domain set. Seven has no pre-image. You're right. So 7 would have a pre-image in 0, but 0 does not belong to natural numbers. So anything, so 7 to 0 has no pre-image. Similarly, 6 would have a pre-image at -1. Again, does not belongs to natural number. Right. So someone has mentioned that 1, 2, 3, 4, 5, 6, 7 has no pre-images. So therefore, uh, it is not an onto. So 0, 1, 2, 3, 4, 5, 6. Sorry, 0 is not right. 1, 2, 3, 4, 5, 6 have no pre-image. But for an onto function, every element in the range must have at least one pre-image in the domain. Therefore, it is not onto and it is only a 1-1 function. Since it is not onto, it cannot be a bijective function as well. So that is why it is only a 1-1 function. So that brings us to the end of our discussion. So if you have any questions related to this assignment or the concepts discussed in this assignment, you can ask, or if you have any other doubt, you can also go ahead and ask, or if you want me to repeat any questions, you feel free to ask. I think no one has any questions. So in that case, we can close the session for today, and you may start leaving if you have no questions left. I have no other thing to discuss today. So there will be one more tutorial session tomorrow on the similar topic, but different questions will be discussed. And again, we'll meet again next week at this time to discuss week 6 assignments. So thank you everyone for taking the time to join this course. I wish you all the best for this course. Thank you everyone.